All right, guys, so let's talk about a piecewise function. So what we're going to do is we're going to evaluate a piecewise function, and then we're going to graph it. So you can see here we have this function f of x. What you have with a piecewise function is we have two separate functions with a restricted domain. In essence, that's really what you have with a piecewise function. And it doesn't have to be just two functions. I mean, it could be multiple. We're just going to work with two functions. So the key thing is that we have this restricted domain. So what that means is you're interested in this function x squared plus 1 when x is less than 0. When x is greater than or equal to 0, you're interested in this function. All right, so let's take a look at evaluating. So if I want to find f of -1, the first thing I need to do is figure out, well, which function am I going to use? Well, -1 is less than 0. So therefore, I'm going to use this function here, x squared plus 1, so that I'm evaluating this function at -1. So -1 squared plus 1, which gives me 1, because -1 times -1 is 1, plus 1, which is equal to 2. So f of -1 is equal to 2. Then we want to calculate f of 0. We have to find out where is the domain. Which domain do we fit into? Well, 0 is greater than or equal to 0, because it's actually equal to, so it fits in here. So we're going to use this function, x minus 1. So that's what we're going to substitute. So 0 minus 1 is equal to -1. And then the last, f of 1. So clearly 1 is greater than or equal to 0. So we're using this function again. So 1 minus 1 is equal to 0. So again, when you're evaluating a piecewise function, whatever value you're trying to find for the function, make sure it's within that domain, and that is the function that is going to be assigned to it. All right, so let's take a look at graphing. So I'm going to take the same piecewise function, and this time I'm going to graph it. So again, the key is the actual domain values here, the restrictions on your domain. So they're both at 0. So less than 0, and this is greater than or equal to 0. So the transition happens at 0. So what I'm going to do is I'm actually going to put a line, which x equals 0 is the y-axis. So I'm going to put a line right here. That's my dividing point. So basically, when x is less than 0, I want x squared plus 1. That's because that's when x, following this domain, when x is less than 0, which is this side, I want the function x squared plus 1. That means I only want to graph x squared plus 1 on this left side. That's it. X is greater than or equal to 0. We want x, the function x minus 1. Therefore, I only want to graph x minus 1 on the right side of 0. And of course, the bar is going to tell us whether we're including the value or not. So let's start with the x squared plus 1. So if we're starting at 0, but we can't include 0, so I'm going to evaluate this at 0. So if I do that and I plug in 0, I get 0 squared plus 1 is equal to, excuse me, let me erase that. It's not 0, it is 1. So when I plug in 0, I get 1 for y. Well, remember my domain here tells me x has to be less than 0, so I can't include it. But I'm starting at that dividing point. So what I do is I put an open circle at the 1. That tells me I'm starting here, but I cannot include it because my domain says less than 0. Let's get another point. Now, there would be no reason to pick 1 because 1 is on the right side of the graph. So I can't pick 1. I want what's on the left side, so the left would be -1. And that would be -1 squared plus 1, which is equal to 1 plus 1, which is 2. So now I can go over to -1, and I got 2 right here. Let's get another one. So plug in -2 So this would be negative 2 squared plus 1, which is 4 plus 1, which is 5. So that would be negative 2 and 5, my point right here. Now that's enough. I know this is a quadratic, so it's going to have a curve on it. So I'm just going to go ahead and graph this part just like that and put my arrow. So you just need to get enough key values there to see what the graph is going to look like. If it's a line, technically you only need 2 points. If it is a quadratic, you want to get a couple just to get the right curve there. So again, because we wanted just this left side, I started at the 0, which is the beginning part, but I cannot include it. I cannot include that. So when I plugged in 0, I got 1, so I had an open circle, because you know what a number line, if you have an open circle, means you're not including that value. Then I plugged in negative 1. Plugging in negative 1 gave me a 2, and I put that point here. And then when I plugged in negative 2, it gave me a 5, and I put that point there, and I graphed. Now I'm interested in the second function, which is the x minus 1. Now this I want when, I'm going to do the table this way, just so I have enough room. I want to start at 0 again, but this time I'm including the 0. I'm including a 0, which means that when I plot that point, it's going to be a closed circle. So if I plug in 0, I get 0 minus 1, which is negative 1. So 0, negative 1, that's a closed circle, because again, my domains tell me I'm including it. I want this when x is greater than or equal to 0, which means I'm including that value. Then I'll plug in 1. Again, it doesn't make sense to plug in negative 1 because that's on the left side. I just want the right side. I just want the right side, so I'm going to pick the next x value, which would be 1. So I plug in 1. So obviously 1 minus 1 is 0. So 1 and 0. Now, I mean, I don't have to keep plugging in points. Again, I have 2, which is enough to graph a line, but I'll do another one. So you plug in 2. 2 minus 1 is 1. So 2, 1, and that is enough. So I'll just go ahead and draw this line as accurate as I can. And that is it. So again, the key point here is to look at your domain restriction here. Identify where you want the graph. So for this one right here, I wanted x squared plus 1 when x is less than 0. That is on the right side. I want this one on the right side only. Then I needed x minus 1 when x is greater than or equal to 0. So that is only on the right side. That is all you graph. You don't graph the whole thing. You have to graph it on the restricted domain. All right, well, hopefully this clarifies evaluating piecewise functions and graphing them. And then, of course, we will move on to another topic.